Okay, this video continues on with our coverage of the Cisco ONS 15454, and we're moving into Chapter 8 of the configuration guide. And in Chapter 8 they talk about what's called the PSM. This is the Protection Switching Module. Okay, and here's the block diagram for this thing. It has both a transmit section and a receive section, and in the transmit section you have an input, you have what they call a virtual photodiode. Somehow they're using firmware to calculate optical power. I'm not sure how that works. You have a 50-50 splitter, two VOAs, and a photodiode to monitor the power after each VOA. Generally speaking, every time you've got a VOA, you can have a photodiode right after it to help you monitor the optical power and make sure that your VOA went to the attenuation that you thought it went to. But after this 50-50 splitter, which is probably a planar waveguide device with the Y branch like I showed in the previous video, we have two transmissions, and they're labeled W transmit and P transmit. W is for working, P is for protection. And so this gives you a redundant signal going through two separate fibers, essentially. These at the receive section, what we have is we have two receive ports, working and protection. We have photodiodes on each. Those photodiodes can detect if the working channel goes dark, for example. There's a 1x2 switch here, and this switch allows us to switch from the working channel to the protection channel in case the working channel goes dark. After that we have a VOA, and the transmission, the output of the receive side then goes on to further components. These cards work in pairs to create a protection switched line. And this next page, 8-5, really shows that really quite nicely. Basically we have nodes A and B, and at node A we have a PSM card, and at node B we have a PSM card. And in between we have 4 fibers, 2 for each direction. The 2 that are in the direction from A to B are shown at the top, where we have the transmit section at A and the receive section at B. And you can see here that both fibers get the same signal because of the splitter, because of the 50-50 splitter here. But this 1x2 optical switch over on the right at the receive section then will quickly switch over to the protection line if the working line goes down, and that working line going down is signified by a big X on that fiber there. And so the same thing happens in the other direction. So you can see how this works. Now, these cards are old enough that they do not communicate using signaling protocol. There's no overhead bytes used. There's no signaling used between these two cards. And so as I mentioned, this photodiode number 3 here, PD3 on the receive section at station B, will detect very quickly if the working fiber goes down, and it'll allow it to switch over to the protection fiber. How does the transmitter know to go ahead and turn up the power in the protection switch? It turns out that they have a bit of a feedback loop here, so that if the working channel from A to B goes dark, the working channel from B back to A, they make it go dark for 25 milliseconds, and that will notify the card at A that there has been a cut over, and that it should adjust its VOAs here accordingly. Okay, it's not the greatest scheme, because that momentary cut in the power from B back to A, which is used as a signal back to A for node B to tell node A that, hey, there was a cut and we had to switch over to protection here. That momentary cut in the power could have also been caused by something else, and so it's not the ideal scheme. And I would say that in most of the new configurations we are using that 1510 channel for communications between the nodes. Okay, that's called either the order wire. I think it's called the order wire wavelength. Okay, that's really it on the PSM cards. The next video I'll talk about Chapter 9 in the configuration guide. Thanks.